All right. Whoa. All right. Okay. So Soundcheck. And oh yeah, I gotta turn the volume down. Okay, Soundcheck. Who is in the room? And can you hear me? If you are in the room, can you hear me? How do I sound? Jeremiah Clark. Where are you from and what test are you preparing for? And that's an example. You can type in your city, state, and SIFT. Okay, cool. Oh man, we got snow again today. So it's really chilly. I made it back in time and stuff because I know when I do these could go to like 11 easy, past that sometimes, and so. You know, as a result, I try to pick up everything I need for the live stream. Okay, who else is in the room? Type in your city, state, and the test you're preparing for. And I would be remiss if I did not put in my email where you guys can take a picture with your smartphone and send questions. So, anybody new to the room, this is pretty much what we do. You get your ASVAB, AFOQT, SIFT book, OAR, ASTBE book, and basically what you do is take a picture with your smartphone, send it to my email, and I execute the questions. So I do this every week, Friday, 9 to 10 o'clock Eastern. And let's see here. All right. I'll leave you here. I'm talking to myself or the computer or the screen, but I'm not crazy, guys. Okay, getting everything positioned here as far as my windows and everything, and we will get started. I had a very interesting tutoring session. There was a pretty tough question, and we were able to get down to the bottom of it and solve it. But all you guys are going to have to be very effective at solving distance, rate, and time questions. So what I'm going to do, or I try to do if I can remember every week, and you guys can remind me if I do forget, but I want to do like a distance, rate, time question, kind of like a different type every week. This one was an expansion one, but it was pretty tough, and I will type it in. All right, let's see if I can get all this in here. I'll get this all in. Okay, it all got in there. No, 238. Okay, my bad. All right, after. That's where the cutoff is at. All right, so I'll send that part, and then I'll send the second part because there's a character limit, and so you guys can see both parts or the entire question. So this was like a really, really interesting one because it is not one of your basic distance, rate, and time questions. A submarine left Hawaii 2 hours before an aircraft carrier. Two vessels traveled in opposite directions. So this is what we call an expansion. When we have two objects that are going in opposite directions, I call that an expansion. That's not like the official name, but if two vehicles or airplanes were going towards each other, I call that a compression. This one I call an expansion because you have two vehicles that are leaving each other in opposite directions. So, opposite directions. The aircraft carrier traveled at 25 miles per hour for 9 hours. After this time, the vessels were 280 miles apart. So, and even if you come in a little late, this is DVRable, so you can see it. But at any rate, so line by line, I say this every week to you guys. It never changes. My structure never changes. You have to stay structured. That's how you get really, really good at solving these problems. All right. So line by line and diagram. So the first line, a submarine left Hawaii 2 hours before an aircraft carrier. So that's telling us that we have, I'll just put AC for an aircraft carrier and a sub for the submarine. These are two vehicles and they are going in opposite directions. You would diagram that on your scrap paper. All right, so the submarine left 2 hours before an aircraft carrier. We're going to hold that. We could just make a little note. Left 2 hours prior. All right, and then the next part, the aircraft carrier traveled 25 miles an hour for 9 hours. All right, so this will be the port, or whatever they're leaving, right? This guy went, and we're going to have a distance, we're going to have a rate, and we're going to have a time on each side. And we just have to count. Now, as long as we get 2, we're going to be good to go. Hey, Caroline, how are you? All right, so as long as we can account for distance, rate, and time, that's what's going to keep us out of trouble. All right, so the aircraft carrier went 25 miles per hour for 9 hours. So that is the rate. I'm going to put 25 mph. And the time was 9 hours. Now, if we have this bit of information, I can find the distance by multiplying 25 times 9, 19, 225. So this tells you that, and make sure, okay, I wanted to make sure I had the right. So we know that this guy moved, the aircraft carrier moved at 225 miles per hour. Now, what it is saying is that after all this time, the 9 hours, okay, I don't know what happened there. I don't know at what point I don't know what happened there. I don't know at what point that looks like we zeroed out too. So basically, like I said, this is DVRable, so you guys can go back. So what I will do is I'll do the recap all over again. So the question states that, wow, I can't believe I dropped off like that. Can't believe I dropped off like that. All right, no big deal. All right. The question stated that a submarine left Hawaii 2 hours before an aircraft carrier. The vessels traveled in opposite directions. This is an expansion question. The aircraft carrier traveled 25 miles per hour for 9 hours. And so rate times time equals the distance the aircraft carrier traveled, which was 225. After that point, the question states that they were 280 miles apart. So you subtract 225 from 280, and you'll be left with 55. The submarine got a 2-hour head start. So 9 plus 2 is 11 hours. Divide the distance by time, and it will give you a rate. 5 miles per hour. Kara, how are you? I lost the signal at some point, but it looks like we're back, and so welcome back, everybody. I don't know what happened there. If you guys could please hit the like button, and we'll check and actually, Kara, we're working that submarine and aircraft carrier question, which I thought was pretty good. Okay. So our SIFT people, OAR, did you say hit the like button? Yes, I did, Caroline. Caroline hit the like button for me. And Erica, you're no longer visible. I see me on my backup computer. All right. So I think last week, we talked about, and I will cover it again. All my OAR people, ASTBE, and SIFT people, you are going to have to be familiar with mechanical comprehension. And basically, Caroline, can you see me now? Everything okay with the video? I'm looking at my screen now. Like I see myself on a big screen, and it looks like everything is going okay. Okay, great. Kara, can you see me? Because she was saying it said an error occurred and that I was no longer visible. Okay, great. Okay, so we worked this problem, and this video is going to be DVRable, so you can go back and look at it. How we executed it, and the problem and the solution. Sorry. So basically, great. All right. So basically, another thing that I want to touch on, and hopefully everybody has this, I want to talk about my SIFT, OAR, and ASTBE people. You're really going to have a working knowledge of physics. There's no getting around it. Should have joined the Air Force. Or tried to join the Air Force, because there's no mechanical comprehension on that. But you're going to have to really have a working knowledge of physics. There's no getting around it. And, I'm going to be throwing in some tidbits, and I'm not going to forget my SIFT people as well. So, since the SIFT guy, Jeremiah, are you still here with us? I hope so. And if not, you can check this out later. But I want to make sure I don't leave my SIFT guys out. You guys come out, see me. No, at least weekly I get one. At least one. Full forces of flight, that applies to everything. Okay. I'll do two. Alright. The maneuver in which a rotary wing aircraft, a helicopter, is maintained by nearly motionless flight over a ground reference point at a constant altitude and heading is known as your options are feathering, auto-rotation, hovering, torque balance, and freewheeling. And the answer to that would be hovering. Okay, so when the helicopter is just sitting there over the ground, constant heading, constant altitude, and it's not moving or anything like that, it's basically just hovering. That's for you, Jeremiah. Another thing that I want to talk to you about is another SIFT question. The foot pedals in the helicopter give the pilot the ability to A. Smoothly enter translational lift, stabilize rotor RPMs, be prepared to auto-rotate at any time, control engine RPMs, and finally control the torque effect. And the foot pedals are basically anti-torque pedals. Basically, when the helicopter, as seen from above, don't laugh at my artwork. Here will be your rotor. We're looking at it from the top. All right. So, depending on whether it's American built or a foreign built helicopter, basically this rotor is going to be rotating, all right, in this direction. All right, so it's going to be rotating in this direction. So what it's going to do is it's going to want to turn the nose of the helicopter to the right. And what you're going to do is you would have 2 foot pedals in here, and you would actually step on 1 foot pedal gently, and it controls the tail rotor, and then that's how you write it. So when a lot of times when you're actually adding more lift with the collective, then what happens is the helicopter is going to want to pivot that way. But you're going to step on this rudder pedal, this foot pedal. I'm calling it a rudder pedal because I'm an airplane guy. But basically, the rotor spinning that way, it's going to want to rotate the helicopter that way. So Newton's third law of motion: for every force, there's an equal opposite force. For every action, there's an equal opposite reaction. So just due to the fact that we have a main rotor turning that direction, it's going to want to turn the helicopter that direction. And what's going to happen is we're going to, if it's going to turn that direction, then what we're going to do is step on that pedal, and then we'll provide more thrust to counteract. And it will push the tail that way, and if the tail goes that way, the nose will go that way to compensate. So that is a SIFT question, and that's all I have to say about that. Let's check in the email. And guys, please check in. Put in your city, state, or state and test that you are taking. Avery, good to see you. Caroline's in the house. Kara's here. Maria is here somewhere. Jeremiah, I hope you are still here because I did 2 SIFT problems. Okay. I'm getting emails. I want something interesting. All right. And the scroll button is giving me problems. And it's another distance, rate, and time problem. All right. Here's the first part. No, that's not what I wanted, guys. Sorry about that. Disregard that one. There we go. And there's a second part, guys, so stand by. And the distance, rate, time problems are like, if you keep yourself structured, you can score points pretty easy as long as you keep everything structured. Okay, a container ship left the Dania Pier and traveled north. All right, so we got a container ship. I don't know. We'll just make it like that. And it's got the little shipping containers on it. All right, but it went north. An aircraft carrier left 4 hours later. And I'll just put AC for aircraft carrier. The aircraft carrier's kind of got the deck and all that good stuff. All right. Don't laugh at my artwork. The aircraft carrier left 4 hours later, traveling at 30 miles an hour in an effort to catch the container ship. After traveling for 8 hours, the aircraft carrier finally caught up. What was the container ship's average speed? So this guy left. 4 hours later, the aircraft carrier leaves. What was the speed? 30 miles per hour in an effort to catch up. After traveling 8 hours, so little crowd participation. If this aircraft carrier traveled 30 miles per hour and finally caught up in 8 hours, how much distance did it travel? And guys, just type in your response. Don't be shy. If you guys get the wrong answer, don't worry about it. I will correct you. $240, very good. Thank you, Kara. So the aircraft carrier leaves, boom, covers 240 miles, and then it catches the container ship. So, what was the container's average speed? All right, well, if this guy was traveling at 30 miles per hour, covered 240 miles, this guy had a 4 hour head start. So this means that, and you have to understand, even if this guy left 4 hours later, if it covered 240 miles, these two ships, they covered the same distance. So this guy covers 240 miles, and with the 4 hour head start, this guy covers 240 miles. And now we have our time, which is 12 hours, because I had a 4 hour head start plus 8, which would be 12 hours. And I could do it in my head, and I could see that it's 20. So this guy was going, the container ship was going 20 miles an hour. Okay, so to recap the question, the container ship left the Dania Pier traveling north. An aircraft carrier left 4 hours later, traveling at 30 miles an hour in an effort to catch up to the container ship. After traveling 8 hours, the aircraft carrier finally caught up. What was the container ship's average speed? So what we did was we noted that the aircraft carrier traveled at 30 miles an hour for 8 hours, which means it traveled 240 miles. We know that even though this guy had a 4 hour head start, by the time the aircraft carrier catches up to it, it still covered 240 miles. So at that point, we understand that it had the 4 hours of travel time plus the 8 hours of travel time that the aircraft carrier used to catch up to it. So that is 12 hours. So 240 divided by 12, which is distance divided by time, will give us our rate. 20 miles per hour. All right. So thanks for that question. And all right. Caroline sends us a question. And this is a class 1 lever. I'm going to write it out on the board. But you sift Navy, Marine Corps, Coast Guard that are taking the ASTBE and OAR. you're going to have to be good at identifying classes of levers. So it's basically asking how much force must be exerted to lift the box. Basically what we have is they have like a bottom piece like this. And they note that the fulcrum is here. And there's 10 feet here. And let's see, there's 30 feet here. Now, Caroline, there's something I don't like about this question. Well, no, you know what? It's okay. Because now I see what's going on. All right, so then what we have is we have a board here. And it is the same length. That was my thing, like, is that the same length? But I'm looking at the diagram. So these two boards are the same length. They're 40-foot boards because 30 plus 10 is 40. And that's really of no consequence, but this board is 40 as well. So we have 10 feet. All right. And we have a 200-pound box here. And the force, yeah, that is still my problem. Because the arrow is here. It's like not on the end. All right. And so I tell you guys about these wacky questions. Because the question is approximately how much force must be exerted to lift the box. Well, we're dealing with load moments. Okay. And a load moment is a function of it's your weight times the distance. So I think of the fulcrum like an equal sign. And the load moments on this side have to be equal to the load moments on this side. And I'll talk about that. So the load moment, which is a function of the distance and the weight. So 200 times 10. 200 is the weight times 10 feet, which is the distance. So this exerts 2,000 foot-pounds. That is the load moment. 200 times 10, 200 foot-pounds. Now, the problem that I have with this is like the arrow's here. It's not at the end of the board. Okay. And so I don't know how accurate. Now let's look at our options. Our options are 67 pounds, 100 pounds, 250 pounds, and 258 pounds. So, if the force is here, theoretically, you're not getting a full 30 feet for your load moment. So we may have to do some tweaking a little bit. But it's okay. We will get to the bottom of this. All right, so let's just assume it was 30 feet. We know we would have to at least do that. All right, so let's say we'll divide 2,000 foot-pounds by 30 feet. All right, 2,000. I'm not going to deal with that. I'm going to chop a zero off here, chop a zero off. And I will get the same answer. All right, and I'll point 0, 0 just in case. 3 can't go into 2. 3 can't go into 20 6 times. 18. Now, I'm done with this question, really, at this point. Why? Because there's only one answer with a 6 in it. So this is a test-taking strategy. After I'll see my 6, and that's going to yield the force that I have to apply. All right, there's nothing else with a 6 in it in the answers. So stop, move on to the next question. All right, don't sit there and work it all out because this is a mechanical comprehension. You want to be able to look at all the questions and try to make a reasonable, but I'm going to finish it to completion. 6 goes into 2018, 2 drops, 6, another 18, that's going to be a decimal, 2, 0 drops. So 66.6 rounds up to 67. But I already knew that was the answer just by getting my first digit. So that is a test taking strategy that I want you guys to understand and be able to use, because time is of the essence. Okay. You're going to see some, easy questions. You're going to see some medium questions, and you're going to see some hard questions. And, use all your time effectively. When I test take, if I got that 6, boom, I'm done. I'm moving on to the next question. And my people, type in clear. I'd like at least 3 clears if you understood it, my explanation, or if I need to recap. If it's not clear, just let me know. 1 clear. Thank you, Kara. Thank you, Caroline. Come on, 1 more, guys. Okay, I'm going to go ahead and move forward. I wanted more clears, but I'm going to go ahead and move forward because nobody's really saying like, oh, I didn't understand your explanation. Okay. Let's go to the email. Okay. I think, this person probably has not been kind of following my videos and stuff. You can type in Keno Thomas and fractions in the search box. And I show you how to effectively deal with fractions very rapidly. I'm not going to be looking for like, oh, the lowest common denominator and all that and everything. It's just simply wasting too much time. And what I teach is time management. Okay, managing your time effectively. So you have more time to deal with harder or the medium to hard questions. So fractions, as far as fractions go, if I have 1/4 plus 1/8, basically I'm going to put the plus sign up here to remind me what I need to do. 8 times 1 is 8. 4 times 1 is 4. 4 times 8 is 32. 8 plus 4 is 12. 12 over 32 breaks down to 6 over 16 and 2, 3, 3/8. So, you go through, okay, let's find the lowest common denominator, find out what to do with the numerators. I don't deal with that. 8 times 1, 4 times 1, 8 plus 4 is 12. 4 times 8, bring that right across 32, and then break down the fraction to its lowest terms. Same thing with subtraction. Let's take 1/4 or 3/4 minus 1/8. Same thing, 3 times 8 is 24. 4 times 1 is 4. We're going to subtract. We're going to get 20 over 32. 20 over 32 breaks down to 10/16 and then 5/8. Done. That is like the quickest, most rapid, and accurate way I know how to teach it. As far as addition and subtraction of fractions go. 1/2 times 1/8. If you were multiplying, we just multiply directly across 1/16. If we're dividing, it's going to turn into a multiplication division problem. So 3/4 divided by 1/2. Okay. We're going to actually multiply by the reciprocal. What I mean by the reciprocal is that the numerator and the denominator, the numbers there change positions. So instead of 1/2, we have 2 over 1, and we multiply directly across. So like I said, the division turns into a multiplication problem. 6 over 4, 3 over 2, or a mixed number, 1 and 1/2. Done. All right. So But type in Kino and fractions, and you can kind of see that full video. I think it's like a half hour, 40 minutes. I think I did a lot of fractions on that one. Boop, 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 boop. Okay. Well, it keeps going away. I'm trying to zoom in. Caroline sent in a question. 100 pounds of force. Volume is area. Area, square area. In the hydraulic system depicted below, the cylinder on the left has a diameter of 2 inches and the cylinder on the right has a diameter of 6 inches. If 100 pounds of force is applied to the cylinder on the left, what force will be exerted on the right? 100 pounds, 2, 6, 100 pounds of force applied to the cylinder on the left. 2, area, volume is equals area times height. Area times height. It really doesn't give you a distance. Hold on. No, it doesn't give you a distance. I'm going to have to do some research on this one, Caroline, because basically most of the questions I deal with concerning hydraulics, they're like square pistons. And you know what? A lot of pistons are round. So I don't want to give you the wrong, I don't want to give you bad information. I don't want to give you bad information. I'm kind of thinking in my head how I would do, because the area of what I'm used to moving, and then they tell you inches, they're just saying 100 pounds of force. That's not typically how, on any debrief, how these questions were presented. But at the same time, I don't want to be, I just don't want to give you bad information. Let me do some research on this question and I will get back to you. Oh man, the trolls are jumping up and down now. They're like, oh, he didn't answer that. Very few questions stump me. But I just don't want to give bad information, because then the trolls will go really crazy if 1, 2, 3. Okay, hold on 1 second. I have to send a quick email, guys. Please be patient. Almost there, guys. Come on. Okay, sorry for the delay, folks. I am back. I saw a question just like that. See it before. No, I guess not. All right. I want to do something interesting. Not the same old, same old. Actually, you know what? I saw another one. And I'm sorry for the delay, guys. I'm just looking for an interesting question, something that we haven't touched on, to just kind of give you something new. Instead of seeing, like, you will see distance, rate, and time problems, but different types of distance, rate, and time problems, because there's many different types and variations. And, you know, I want to give you guys the tools to kind of look and be able to process them, or have video information just showing, like, okay, this is how I process them. Okay. This is a system of equations problem. It's one of my, I like systems of equations because, you know, when I started learning them, I was like really, I wasn't very good at it. And now, not only am I good at it, I'm very good at showing other people how to do them. So system of equations are, I don't know, to me, they're kind of cool. Let's see if I can't take this and paste it onto the come on, buddy. All right, I'll just do it on the board because it looks like something's hanging up. So in a system of equations, what we're doing is we're taking two separate equations and we're simultaneously solving them. The reason why is because we want to know where these linear equations intersect each other at, where the two lines cross each other at, negative 12 and negative 24. All right, so this is not bad. It's almost even like set up. Let's get some more color in here. So basically, we line these up, and this is an X. Sorry about that, guys. All right, so this is already set up, and basically what I call the process, and it may not be the official process, but I call it adding downward. So you have the X row, the Y row, and the number row. Now, the X's are going to cancel out because 4X plus negative 4X and 4X is going to be 0X. So we'll deal with the 2 and the 8Y, and we're going to come up with 6Y. Now, we have to deal with this, and this is, we add those, this will be negative 36, and our Y coordinate is going to be 6, because 6 times 6, actually negative 6, sorry, because that's a negative 36. Caught myself. So the Y coordinate on the Cartesian coordinate plane, if you remember your x-axis and your y-axis, The y coordinate is going to be 6. So we're trying to find out where on the graph these two lines intersect each other at. So after we get negative 6 for y, all we need to do is just substitute. So we're solving for x now because now we know y. So 4x, and you could use either equation, does not matter, plus 8, and then we plug in negative 6 in there, and then equal negative 24. I'm running out of real estate. So 4x plus, or actually minus 48, because 8, positive 8 and negative 6 multiplied together will be negative 48 equals negative 24. So now, how I say this, because some people will be like, oh, add 48 to both sides. I say the 48 jumps the equal sign and becomes positive. So if that happens, then 4x is going to be equal to positive 48 minus 24 will be 24. 8 minus 4 is 4. 4 minus 2 is 2. So x is going to be equal to 6. So these two lines intersect at 6, negative 6, which if we go 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6 up, 6, negative 6. That's where these two lines cross each other at. So we've simultaneously, and another thing, if you really want to go through the length of double checking that you see if it works in this equation too. We tested it here. But if we plugged in a positive 6 for x, it would be negative 24. And then a negative 6 here would be a positive 12, because negative 2 times a negative 6 would be positive 12. And negative 24 and a positive 12 result in a negative 12. So I've tested it out in equation 1 and equation 2. All right. Good question. And looks like let me do one more SIF concept, because I don't really concentrate on my SIF guys probably as much as I should. And this channel is for all military aptitude test prep and Federal Aviation Administration people. There's a concept that you must understand in main rotor aerodynamics. If we have a propeller, I'm saying propeller, main rotor of the helicopter, and this thing is rotating counterclockwise and we're in forward flight, then we need to understand that we have what we call an advancing blade advancing, and we have a retreating blade. For this concept in forward flight, when this main rotor swings from the 6 o'clock position to the 12 o'clock position, it is actually moving faster than the helicopter, actually, this blade, because it's attached to the helicopter. It's already moving at maybe, I don't know, let's say 100 knots. Or a term everybody can really deal with, 100 miles per hour. So for that second that this rotor blade is being spun forward, it's actually faster than 100. And then when it gets to this side, it will be the retreating blade side. So we cut this up like a pie. This will be the advanced side. This will be the retreating side. All right. So that's the concept of the advancing and retreating blade. At this portion, when this thing is whirling around, this is when it is a advancing blade. And let me use another color. When it gets to this side to the 12 o'clock, around to 6, this is the retreating blade. And although the helicopter is moving at 100 miles per hour, the blade is moving, I won't say slightly faster, much faster, because helicopter main rotors, they spin pretty fast. So, advancing and retreating blade, we have about 5 minutes left. Okay, so it's my time to close. If you guys are interested in the Google Hangout, this is for my clients only. Send me the email. What else did I want to say? Okay, so yeah, that was another successful live stream done. I thank you guys for taking time out of your evenings to come and visit my channel. And all my clients, I thank you for choosing me as your tutor. What else? For people new to the room, if you are having problems, because, your recruiter goes, oh, you can go get the book and just take the test and see how you do. And you go out and you purchase a book. All right. On any of the military aptitude tests. This goes for my Federal Aviation Administration aviators as well. My civilian guys. This is the place to get your questions answered. You're going to go through the book. A lot of the things you will understand. But there's going to be a lot of things that you probably won't understand. And that's where I come in. What else did I want to say? That's really about it. Recruiters, military recruiters. I know you guys do a tremendous job going out there and putting in the work. But a lot of times, recruiters would tell people, oh, go ahead, take the test, see how you do. For the ASVAB, you can do that. I don't think there's like an unlimited. There might be an unlimited, but there's not a cap on it. Like the ASTBE or the OAR, you only get 3 times to take it. The AFOQT, you only get 2 times to take it. So this is not something that you should really take lightly and stuff like that. And if you don't come to me, go to somebody. You can Google. You can go on YouTube. There's a lot of people that deal with these things. And, don't play with this test, these exams. You are taking this test to place for a certain job. And some people, you might be really passionate about, oh, I want to go into, I don't know, ASVAB. I want to be an electrician. Well, if you're not really that familiar with the electrical information questions, they're probably not going to want to send you to that school. And the military is not going to do anything. They give you a test to see where you place, to see if you're even trainable, So that's my little spiel. 1 minute left. So I'm going to close out so I can go to my Google Hangout. If you guys are interested, send your emails. And I'll talk to you guys next Friday. So again, I thank you guys for watching. I'm Kino with STEMwithKino.com. Really, really thank you guys for watching. And have a good night. And this is where I do my little finger thing. I don't know, it's just, they got a different little button or icon thing. That's not it. I feel like Eddie Murphy and Delirious. That's not it.